Thanks a lot, Ted. Never let it be said that as engineers we're completely stupid. We have learned. We've been watching V6 and its transition mechanism and watching the way in which you've responded to an incremental change that's totally disruptive in your network and thought, well, maybe that's not the way to do it. And the one in particular that I think we've learned from is actually this issue about the other kind of exhaustion that's flying around, which is the exhaustion of AS numbers. So I want to talk a little bit this morning about 4-byte AS numbers, 32-bit AS numbers, and take the view that where almost all of you are today, in your router, you don't understand them. What your router has is a 16-bit AS number machine. So what does the world look like when some of you start incrementally deploying 4-byte AS numbers? So that's the perspective I'm trying to take here. Here's a graph, lots of lines. What I'm trying to do is predict when those 4-byte numbers are actually, sorry, the 2-byte numbers, the current number pool of AS numbers is going to exhaust itself. So what I did was look at the total number of AS numbers out there in the field, look at the stuff that I can see in BGP, and not all of them are in BGP, and look at the stuff that isn't in BGP and predict those outwards, and at the same time look at the supply side. How many are left with IANA? Right now IANA have around 21,000 AS numbers left. And then look at the RIRs below that and try and figure out when will the first RIR say, nice try, haven't got any left, sorry, can't do it. So that model, and what I've done is using an exponential growth model with a very, very small exponential factor, which correlates almost precisely over the last 4 years. So there's a pretty high certainty on that prediction. We're looking at an exhaustion time of around 2100 UTC on the 29th of October 2010, plus or minus a few minutes. Obviously, you might change that if you do a rush on it, but I'm there, I'm tracking you. Every day I look at the numbers again and publish that at that URL. So yes, I'm watching this quite tightly and revising the predictive model every day. So yes, we are running out. Yes, you have approximately 4 years-ish, a little under 4 years, and yes, there is some work to do. So what we're trying to do is to do something radically different to this industry and do something I think that is almost completely novel. We're trying to plan. And what we'd like to do is to actually allow those folk who wish to do this early, and actually obtain a 4-byte AS number and start using it. And phase it in so that at the point when we're running pretty close to the bone here on the old 2-byte numbers, we then start flipping the model. So the RIRs across all of the RIRs have adopted the following procedure that as of today, in fact as of the 1st of January this year, if you want a 4-byte AS number, ask for it. If you don't ask for it and you just want an AS number, you'll get a 2-byte number. Fine. However, in just a little under 2 years from now, 1st of January 2009, when we still have some 2-byte numbers left according to the model, when you ask for an AS number, we will give you a big one, 32 bits with a non-zero high bit, unless you explicitly say, I'd like a small one. I don't care why. None of the RIRs care why you might want a small one, but there's enough there to satisfy it. But if you really don't care, and hopefully by then there'll be vendor implementations will have finished and you'll be deploying this stuff anyway, by then it won't matter. So that's the current policy regime. Now I'd like to take this view of, well, what does this 4-byte number transition look like, and will you need to start kicking your routers in the head even though you're not deploying one? I'm deploying it. What's the change to you? So the 4-byte AS number transition, like I said, is not a V6 thing. It's not an incremental change with massive disruption. It's actually an incremental change with almost no disruption. We're changing as little as possible in the BGP spec, and if I'm speaking 4-byte and I'm peering with someone speaking 2-byte, eBGP or iBGP, the first thing on the open is to negotiate what kind of neighbour I have, 2-byte or 4-byte. And I adjust my behaviour as a 4-byte speaker if I'm peering with a 2-byte speaker. And if I'm peering with a 2-byte speaker, I adopt an artificial persona. I become someone subtly different who is 2-byte compatible. So the 2-byte speaker thinks they're talking to a 2-byte speaker. So this is entirely backward compatible. It's the 4-byte speaker who has to do all the hard work. If the 2-byte speaker says, I'm 2-byte, I just don't understand this stuff, the 4-byte speaker goes, okay, you want me to speak in 2-byte language, I'll speak in 2-byte language. So I use a 4-byte persona with my 4-byte peers. If I negotiate and you're going, yep, 4-byte, then everything is in 4-byte AS numbers. All the update messages and so on use the extended 4-byte message. What happens? I preserve the basic AS semantics in BGP. An AS path actually isn't intended in the strict sense of the protocol to express where and through which ASs the packets may be transited. That is not the intention in a strict protocol sense of the AS path. You might think you're using it that way, but in protocol terms, that's too much information and you don't use it. The reason why you have an enumerated path is actually to do very fast loop detection without the count to infinity problem that is classic in most distance vector. As soon as I see myself in an update, that's a loop. So in actual fact, when I look at the AS path, all I'm looking at is to see my own AS number. I don't care about anyone else who's either seen it or not. It's not my problem. My problem is my AS number in that path already when I receive an update? And secondly, BGP default path selection is to select the, quote, cheapest path, where cheap is a metric of AS path length. So I need to know the cheapest path. I need to have the length of the AS path preserved. But all I'm looking for is myself and the number of entries. In a protocol sense, that's all you have. So you can lie in the AS path, and people do it all the time. You can, and the protocol still works. So in the 4-byte, 2-byte transition, that's what we do. And there is no flag day. Nothing happened on the 1st of January 2007, and your router, if it's doing a full route feed, already has at least one embedded 4-byte AS advertisement. I know because I put it there. So what I've got is this model that says 2-byte implementations, you can run them for as long as you like. It doesn't matter as long as your AS number is 2-byte. You can run indefinitely. And the deployment of 4-byte can be as piecemeal as gnats. You can do it, I can do it. And in essence, that information will be correctly mapped across the 2-byte BGP ocean. So piecemeal deployment of 4-byte will work. So what's changed? Well, when I'm talking as a 4-byte to a 2-byte, I'm going to lie in bits of the AS path. Those AS numbers that have non-zero high-order bits, that actually have the up-order 16 bits non-zero, I can't tell you about them. So I'm going to tell you a funny AS number, 23456, which is a token holder. The 2-byte compatible wildcard for big numbers I can't do. And the other thing is that the update messages themselves will be bigger. There will be more information when I'm a 4-byte speaking to a 2-byte. And the updates you carry across the 2-byte world will be larger in size. There will be more bytes in that message. But, as you see if you care to look, prefix reachability information is still communicated. The prefix that I'm advertising using a 4-byte AS origin right now today, you will see and you will do your correct decision in terms of how do I flick packets to that destination. Nothing breaks. When advertising that prefix of 4-byte origin, I'm still connected. So what does this imply? If you're a 2-byte AS, and almost all of you are today, and you've got no interest in disturbing a stable operation of BGP, you don't want to kick your router in the head, and something that none of you really want to do if you really get down to it, then in actual fact, nothing changes. You don't have to do anything at all. Nothing changes. You can watch the rest of the world do what they do. You don't have to change. So, that was logically where I ended. But as always, I've got 30 minutes, so I thought, well, I might take a little bit more time. That's not quite true. Other things will change, and you will have to be aware of them. I said before that the AS path is two things strictly. It's a metric. Shortest path wins by default. And it's a loop detector. I'm looking for my own AS. I don't care what else is in it as a BGP speaker. I'm looking for myself. So the way we do the transition is actually when a 4-byte speaks to a 2-byte, we use both translation and tunneling. And we tunnel the 4-byte information through the 2-byte world. What we have in BGP are transitive, opaque attributes of an update. And a transitive, opaque attribute has the semantics that if you don't understand these block of bits, store them in your rib, and when you on-advertise, just replicate them. Don't change them, don't try and interpret them. They're opaque to you. If you don't understand them, do nothing. That's tunneling. So I have a very quick example here to illustrate the approach. 2.0, it's a big one, talks to 2.2, it's a big one, talks to 1.2.2.1, it's one of yours, talks to 4.6.33.7, one of yours, talks to 2.3. So in the ribs, when I start, it's just an internal route given to me by my IGP. And I send that to my neighbour, 2.2, and it's a normal BGP update, but it uses longer AS paths. So I send 2.0 in the update message. This originated from 2.0. And in the rib, that'll put in that, this is the path attribute I received. But 2.2 knows that it's talking to a 2-byte. It knows that something weird has to happen. So when it sends the update along, it adds itself to the path, but then translates both of them because they're not 2-byte numbers, they're 4-byte numbers. So it sends an update with 23456, 23456, same length, but I'm lying. But I also send in an opaque attribute the actual AS path. At the time it entered the 2-byte world, it was 2.2, 2.0, and that's hidden inside a new AS path, transitive opaque attribute. 1.2.2.1 will put in its rib 23456, 23456, but it will store that opaque attribute so that when it sends the update on to 46.37, it keeps that attribute as it received it, 2.2, 2.0, and now the AS path starts to form as normal, 1.2.2.1, 23456, 23456. No magic here. In the rib in 46.37, the path as translated, in other words, 1.2.2.1, 23456, 23456, and it sends to the new BGP, because it's a 2-byte, it just sends that transitive opaque attribute once more. The 4-byte receiver goes, aha, I've got to join the beams again. And it substitutes back the 4-byte information in the transitive opaque attribute that it understands. I understand this. So it now rebuilds the path as if the 2-byte intermediaries were 4-byte. Presto, I get back a coherent 4-byte AS path. If a loop forms, I can see it in 4-byte world. Everything works. So now in the rib, I have translated attributes in the 2-byte world, I have real attributes in the 4-byte world. Life is fine, enjoy. So, you know, I'm an old BGP speaker, what should I look out for? Because BGP will just work. Don't muck with transitive opaque attributes, please. Please don't muck with it. It's not a, you must not muck with it or the world will collapse as we know it. It's a plea. It's a please don't. If you do muck with it, and if you don't hand it on, loop detection will be longer. It will take longer to converge on a withdrawal because the loop will go for much longer than you thought, but the loop will still be detected and found. But the loop will only be detected in the 2-byte world, not the 4-byte world. So the default, you pass it on, is just fine. If you really want to get remarkably anal about the way in which you treat these transitive opaque attributes and drop them, that's not a good thing, but the world won't collapse. When you do proxy aggregation, you also generate a new aggregator, an aggregator attribute. If a 4-byte world wanted to do it, there will be a 4-byte aggregator. That won't work. Again, there's another new attribute, new aggregator, transitive. Leave it alone. Default is fine. Just pass it on. If you choose to strip it, well, you know, nothing fatally breaks in terms of loops, but it's not a good idea. It just takes longer to detect the problem. And if you're worried about what's in AS paths, then 23456 is a wildcard for the rest of the world. And it's going to appear everywhere. It's going to be origins, it's going to be transits. It's going to look a remarkably strange AS from your point of view. It's not an error. It's a wildcard that said down there in the opaque attribute area, there's actually the real AS number. It's not yours to understand. So 23456, if you're worried about filters, ACLs, all that kind of stuff, 23456 is a bit of a wildcard for you. If you're doing net flow, then if you're working on 2-byte, you're going to get an awful lot of net flow with 23456. And that's going to be a little bit interesting to try and understand because it stands for many ASs, not just one. If you really want to do this, then if you want to detect the 4-byte, A, you've got to run 4-byte BGP, and B, you've got to run NetFlow version 9 at least, because NetFlow version 9 is the first one that actually allows AS numbers to be 32 bits. Your analyzer that analyzes NetFlow, does it support 4-byte? Because if you start presenting it with NetFlow version 9 and longer AS numbers, what does your analyzer think? Version 8 and earlier can't run with 4-byte. They're actually 2-byte constrained. If you're using communities to signal, then in the 2-byte world, you can't signal to me in the 4-byte world. You just have no way of doing this unless you also hook up your BGP to run extended communities. So the reference is that if you're looking to do this, you will need to be compliant with RFC 4630, extended community attributes, and using the signaling mechanism as defined in that draft. So if you really want to be in the 2-byte world and send me a signal via a community attribute that I'm going to receive, you're going to have to at least do 4630 extended community attributes and that signaling. I said before, BGP updates will increase in size because now when I send you a path, you will have the path and the 4-byte version of the front of the path. So the 4-byte version, it takes twice as much to store each AS, and I'm going to be actually having larger updates. So in the worst case, what's going on is, of course, if I'm a 4-byte speaker, I'm internally 4-byte. Every AS path doubles in size. If there are 50,000 distinct AS paths, that used to be 100,000 bytes, it's now 200,000 bytes. So the amount of memory required to actually run BGP is higher. Even if you're a 2-byte world, you will notice the memory to store paths will increase. Why? Because the new AS path attribute is tacked in. So you're going to have to store that. So you'll need to hold not twice the memory, but twice the pool of memory you use to hold AS paths, twice the memory plus the original. So you may need to hold up to 3 times the memory that you're originally holding paths in. Those are big updates, same as in memory, same as in updates. I'm going to use twice the update size in 4-byte to 4-byte, and I will use up to 3 times the size of the update message that is used to carry the path. Not the entire update, just the section in the path might blow out by another factor of 3. Performance. I actually did a hack on OpenBGPD and actually implemented 4 bytes in BGPD and thought, geez, this is cool. I loaded up the full routing table. Gee, this is cool. I then brought up a 2-byte neighbor. It didn't work. Why? Because OpenBGPD generates all of the updates before sending anything on. And it froze doing a massive amount of path computation internally in the engine. So if I'm starting up a session and I'm 4-byte and you're 2-byte, I have to do a lot of work per path because I've actually got to generate, if you will, the 4-byte equivalent and strip down the path that I had in my RIB. So session startup may be really slow because the 4-byte speaker has to do a huge amount of work. And for about 35,000 unique paths, which is what some of you see a lot more. That's a lot of computation. And starting a session up, depending on the way your BGP engine works, may take longer. If any of you don't like transitive opaque attributes and strip them, you're going to cause some of us some pain because convergence times may increase. If you destroy that new AS path attribute, loops will take longer to detect. The update message will travel further before someone sees their own AS because you've just destroyed all of the 4-byte ASs. So none of the 4-byte folk can see the loop. It's not that you've just uncovered infinite looping. It's not that you've done something really bad. You've done something that makes the BGP convergence process take more time. So please don't do it. If you proxy aggregate right now, just make sure that the proxy aggregate you actually advertise is larger than all of the components that you're using as seed inputs. Because when you proxy aggregate, you will destroy the new AS path attribute. It will have no meaning after proxy aggregation. So make sure that the aggregate is always larger than all of the specifics you're using. Otherwise, I can't guarantee that looping won't happen. Looping may happen. So if you do proxy aggregation, and almost none of you do, most of you seem to do it for about an hour or so and then go, that was really cool, I'll turn it off. But if any of you are doing this all the time, watch out. I've got this long-held session. It's really cool. I'd like to turn it to 4 byte. Stop, shut down, no graceful restart, clean restart, right from scratch. You can't flick an iBGP or an eBGP session into 4 byte mode. You just can't do it. You've actually got to tear the entire session down and then do a clean start using the open negotiation and capability exchange. Nothing else works. I'm not sure that all of you will flag day your internal network. If you really do want to move ASs, there's a merger, an acquisition, all of a sudden the other guy's AS you're merging with prevails and it's a 4 byte. I've got to change my AS into 4 byte. I've got all these iBGP speakers. You can do it because the same mechanism works iBGP, eBGP. It makes no difference. But think hard. Test it in the lab. Some things are not obvious, particularly with a lot of other configuration and signaling. You can do this one router at a time, but don't put the guy who started last week onto the project, okay? That won't work. How do you describe these? Oh God, we've had so many debates about notation. You can either start using really, really big numbers. I must admit, I don't like it personally, but some of you like it, and fine, you can use really, really big numbers. I'm actually a keen proponent of the dotted short int, 2.3, 1.2, high order 16 bits, low order 16 bits. It's just the way I think. And some folks say change nothing that doesn't need to be changed. The dotted short int plus, if it's less than 65,000, just write the number. If it's more than 65,535, write it as A.B. The implementation I patched will accept either, but report only dots. Other implementers in BGP probably have their own style, but right now we haven't converged on a single notation. What about your operating support system? Oh dear. Many folk use the AS number and tie it to the customer and load up configurations and filters automatically. So what happens when a customer comes along and says, I'm 1.2? What do you load into your router? Filter lists about 2, 3, 4, 5, 6. So somehow in your current OSS right now, you need to think about, what if I peer with someone who's 4 byte? What if I have a customer who's 4 byte? What if one of my transits is 4 byte? Will my current operational support system do the right thing? And by do the right thing, hopefully it will understand 4 byte AS straight away, because otherwise you get confused. Which AS was I talking about? But when you get your system to automatically generate filter lists, to automatically do AS path filters, just remember that if your router is old, 2 byte, the filter is going to be a 2, 3, 4, 5, 6 filter. And then think about how many peering sessions that filter is applied across. Because if I filter for you and you're 4 byte, I do a 2, 3, 4, 5, 6. If I pass traffic from you, 10.3, through the same filter, 2, 3, 4, 5, 6 is going to get smacked both times. You may have unintended results. Be very careful about your OSS. Obviously, the regional internet registries are now sending this stuff out into the wild. Obviously, they're going to have to do changes to report correctly. So internet route registries and RPSL is going to have to change, who is, and so on. I think Henk is going to talk about that in the next presentation. Any piece of software you have that manipulates AS numbers, you've got to recognise that very, very soon, possibly tomorrow, a customer might have said, I want to play with big numbers. Here's my big AS number. Route me. So what about if you want to play with this stuff? You can play with this stuff right now. There are patches available for Quagga, which is the old Zebra on steroids. There are patches for OpenBGPD. I did some myself to 3.9 and 4.0, and the OpenBGPD folk are now working on it, integrating that into their mainline right now. And I believe that the Junos folk can jump up and correct me, that Junos E410 and later, and I don't know the version numbers for Redback. What did I patch? When I patched Open BGPD, it wasn't very hard. You change the data structure, everything is 4 bytes. You change the parser to recognise A.B. You alter the open processing to say, I do 4 byte, do you do 4 byte? And then you alter the update processing. When I send a message to a 2 byte, I go and do the new AS path thing. When I receive an update message from a 2 byte, I do the reconvergence with the new AS path. Not a very big set of changes. The patch set is actually quite small. Have we tested it? Yes, we've tested it. Is it being tested right now? Yes, it is. If you look for 203.10.62.0/24, you will actually find it originates from AS 23456, unless you're running something that understands 4 byte, in which case you will see that it really originated from 2.2. If you look at it in route views, you'll see this, 23456, because route views is a 2 byte BGP. And I actually did this across the live internet on January the 11th and found that it works just hunky. And this is one of the immediate tests where you just go straight through 2 byte and back to 4 byte, and yes, you see the correct path back again, and the originator is actually being advertised correctly as a 4 byte. So realistically in BGP, no, nothing changes. Everything just works. You don't have to do anything. The internet won't crash and burn because of 4 byte AS numbers. Phew. Will your operating support system do the right thing when a customer, a peer or a transit fronts up with a big number? I don't know. You better find out, because that might happen tomorrow. So you need to ask yourself what will happen if you get 2 customers with a big number, 3 customers with a big number. Are you going to get terminally confused, or will the right thing happen? There's an IETF spec. There it is. It's now at version 13, I believe. The patches that I did to Open BGPD are at that URL if you actually want to play with it. FreeBSD doesn't understand 4.0, so 3.9 actually works perfectly on FreeBSD. That's when I did all my testing. And the Quagga folk, or at least not the Quagga folk, but some folk are working on this and submitting it to Quagga, and their patches are over there. So if you want to play, it's actually really quite cool to play. You can go and get an experimental allocation from a regional internet registry, and you can play today. Thank you. Questions?
Yeah, we have time for a few questions if we want. And Hank, if you can come up while we take questions, that would be great.
So what I heard an NANOG ago was someone saying, oh my God, will I not see anyone who advertises with a 4 byte AS origin? Am I breaking connectivity? And hopefully I have demonstrated to you, or at least given you some confidence, that that is not a problem. Connectivity is connectivity. This will just work. I'm glad you share that confidence then.
Great.
Thank you.
Thanks, Jeff.